Okay. So once again, good afternoon to everyone. Okay. My voice is clear. I'm audible. Yes, my screen is visible. Hello. Yes, I'm audible. Okay. So we'll start. So today we are going to study the two types of filters in a image restoration. Okay. So it will be the last point of our fifth unit. Okay. So it will require hardly 10 to 15 minutes. So everyone listen carefully. So what is the basic meaning of a inverse filter and winner filter? Okay. So in yesterday's lecture, we can studied the estimation of a degradation model. So in estimation of degradation model, we can study the three different ways to estimate the degradation function, or we can call as a estimation function H. So the three techniques are estimation of a degradation model by observation. Second, estimation of a degradation model by experimentation. And third, estimation of a degradation model by mathematical modeling. Okay, so in observation, we can compare simply the two images, and by looking at a structure of a two images, we can easily estimate the degradation function. Okay, so in second technique, in second way, so by doing a experiment, yeah, by doing a simulation, we can also find out the degradation function H. So for that, we can consider one impulse image, and we take the impulse response of a particular image. Okay, and in third technique, we can use the mathematical modeling. Okay, so for this, we can use the different atmospheric turbulence factor, that is denoted by a K. Okay, so by using this, we can take the example of different turbulence factor. So it is a we can take the negligible turbulence, we can take the value of K point not 25. So we can take the different values of turbulence, and we can identify the noise level in a image. Okay, so these are the part of degradation model. So by using these three techniques, we can estimate the degradation function. Okay, so what is the need to estimate the degradation function? So when we study the image degradation model, okay, so in image degradation model, we can study the filtering element. Okay, so here we can use the two types of filters. One is a inverse filter and another is a winner filter. So what is a inverse filter and what is a winner filter? So that point we have to study it in our today's lecture. Okay, so before started with this type of filter, so we can also study the different types of filters in our unit number 4. So we can study the low pass filter, high pass filter. Okay, so in low pass filter and high pass filter, we can study the three different types, that is ideal, right, Gaussian and Butterworth. Okay, so we can study the different types of filters by using the mathematical functions and also by using the various plot functions. Okay, so basically the filters are used to remove the unwanted noise from an image. Okay, so here we have to use the two types of filters in an image restoration. Okay, my voice is audible. Okay, my voice is clear. Hello. Yes, my voice is clear. Okay, so everyone listen carefully for a 10 minutes. So we have to start with the inverse filtering. So there is a one and there is a winner filtering. So how we can use the inverse filter and how we can represent the inverse filter. Okay, so basically the two types of filters are used to restore the image. So how we can restore the image? So in order to restore the image, simply we can remove the noise which is presented from the image. So what we did in an image enhancement, so in image enhancement we can take a random image, so we are not dealing directly with a noise. Okay, so in image enhancement, simply we can improve the quality of image. So if the noise is present, so we can remove the noise with the help of various filters. Okay, but in image restoration, okay, we can deal with a noisy image. Okay, so it is the basic difference between image enhancement and image restoration. So what we did in a image enhancement, so in image enhancement we can deal with the image and we can simply improve the quality of input image, and if the noise is present, so that noise can be removed by using various types of filters. But in image restoration we can deal with a degraded image, so that is called as a noisy image. So here we can take the opposite action, so that's why it can called as a inverse filtering. Okay, so how to represent the inverse filtering? Yeah, why it can called as a inverse filtering? So here uh, by computing the function, so first we can represent the image into the x and y coordinates. Okay, so if we restore the image, अजून जॉईनच होत आहे का रोल नंबर 10? It's 146. Okay, okay, wait a minute. Mm. Okay, so in inverse filtering, first we can compute the function which is in the form of u and v coordinates. So now how we can compute the function? Yeah, how we can restore the image? Okay, so when we restore the image, so while, yeah, at the time of restoring image, where we are not able to restore the 100% data of a image. Yeah, we are not able to remove the 100% noise from an image. So for example, if we scan a pen drive, so at that time we are not able to remove the 100% virus from that device. So some of noise can also be presented in the image. So that is represented with the n of uv. Okay, so when we restore the image, so at that time we are not able to restore the 100% noise from a image. Okay, so here with a original image, so here we can represent the image with the help of f of uv. Okay, so everyone concentrate on a second equation. So f dash of uv is equal to f of uv plus n of uv divided by h of uv. So when we restore a image, so at that time there is a little bit noise can also be presented with the image. So that is represented with the n of uv. Okay, and that noise is divided by a degradation function. So here we have to remove the maximum noise from an image. But when we use the inverse filtering, so at that time a little bit noise can be presented with the image. Okay, so if we consider this equation, so we know the degradation function can be represented with the h, but we are not able to recover the 100% noise from an image. Okay, so whatever the noise, that noise can be represented with the n of uv. Okay, so in order to make it zero, we are divide the noise n of uv by a degradation function h of uv. Okay, so in this way we can remove the maximum noise level from an image. Okay, so when we use a inverse filtering, so at that time when we recover a image, when we restore a image, so some of noise can be presented with the image. Okay, so here we can also use the different types of filtering, that is called as a winner filtering. Okay, so the winner filtering also called as a maximum mean square error filtering. Okay, so it can also called as a, in a short form, MMSE filtering. So might be in an exam there is a short note explain the MMSE filtering. So instead of a full form, we can also called as a MEMSE filtering. That is a maximum mean square error filtering. Okay, so by using the winner filtering, we can remove the maximum noise which is present from the image. So how to represent the winner filtering? So here we can use the equation, yeah, we can call as a expected value of argument e. So here we can use the equation as a e square is equal to e f minus f dash square. Okay, so what is a e function? So here we can call capital E as a expected value of the argument. How the noise is presented in the image, yeah, how we can remove the noise from an image. Okay, so that factor we can calculated in winner filtering. So when we calculate the winner filtering, we have to make a certain assumptions. Okay, so we have to correlate the image and the noise level. Okay, so how much the noise can be presented in the image, what is the noise value, it is a maximum noise or it is a minimum noise. So that thing we have to consider in a winner filtering. Okay, so when we use the winner filtering, we can convert the image, yeah, we can use the degradation function. So first we can convert the xy coordinates into the uv coordinates. Okay, so based on this condition we can represent the winner filtering in terms of the u and V coordinates. So here we can take the yeah, here we can consider the degradation function. Then it's a complex conjugate equations. So by using, okay, so if we look at the equation, so by using the various parameter, we can consider the mathematical equation for the winner filtering. Okay, so basically the inverse filtering and winner filtering are used to remove the noise Okay, so in an image restoration, these two types of filters are too important. One is the inverse filtering and another is a winner filtering. So how we can represent the winner filter and how we can represent the inverse filter. So when we use these two types of filter, we need to estimate the degradation function. Okay, so we require the degradation function that is represented with the h of uv. Okay, and for estimating the degradation function, we can study the three different techniques. Okay, so it is related to the two types of filter. So simply the mathematical equation and its represented, sorry, its representation with a degradation function h of uv. Okay, so our fifth unit consists of the four main points. So the first point is a degradation model. Second point is a various noise models. The third point is a estimation of a degradation model, and the fourth point is a filtering element. Okay, so in noise models, we can study the different types of noise models and its mathematical representation and a plot function. And the in filtering element, we can study the two types of filter. One is a inverse filter and another is a winner filter. Okay, so here we can complete the unit number 5. Okay, so when we study the unit number 5, we have to study these 4 points. Okay, so the question might be on any 2 points. So it might be on a noise model or it might be on a degradation model. Okay, so in a image restoration, the 4 points are too important. So once again, I'll revise these 4 points. So in a first point, we can study the image degradation model. So the objective of image degradation model is that we have to restore the degraded or restored image, and we have to bring the image to its original quality. So simply we have to remove the noise from a image. So in second, the second point is a different types of noise models. Okay, so first we can study how the noise can be added in an image. So there are two possibilities. So first possibility is the at the time of image acquisition and at the time of image transmission, the noise can be added in the image. Okay, so how we can identify the noise? So to identify the noise, we can study the different types of plot functions. And by using the mathematical equations, we can represent the 6 different types of noise models. The third part is estimation of degradation function. So in that we can study the 3 ways to estimate the degradation function, that is h of uv. And the last point is there are two types of filters. So one is an inverse filter and another is a winner filter. Okay, so the fifth unit consists of these four important points. Okay, so here we complete the unit number 5. Okay, so the up to the unit number 5, so the first 5 units related to them. Okay, so here we can complete the part of image processing. Okay, so there are two more units which are related to the video processing. So on next lecture we can start with the video processing. Okay, so it consists of 2 units. So in video processing we have to understood how we can represent the video, what is the meaning of video. Okay, how we can store the video, what are the different techniques. So if the noise in video, how we can remove it. So that part we have to study it in a video processing. Okay, so you have any doubts in these 4 points of image restoration? Okay, okay. So I'll share the notes and PPTs of unit number 5. Okay, so in upcoming lecture we can take the MCQ test on a unit number 5. Okay, so I'll share the MCQ materials from unit number 1 to unit number 7. You can go through it and also share the notes up to the unit number 5. Okay, so if you have any doubt, you can ask here. Okay, any doubts? Okay, so this time also your exam is online. So might be your exam pattern is on a objective questions only. So you have to prepare for the MCQs also. So to prepare the MCQs, we have to study the each and every concept in a detail. So you can go through the all the notes, all the MCQs, and if you have any doubts, you can ask. Okay. Okay. So today we'll stop here. You can put your attendance. Okay. Once you put your number, now you can left now. Hello.